Welcome to another edition of RockSim Live. I am Tim Van Milligan. I'm your host, and I am here to answer your questions about RockSim, RockSim Pro, or the Launch Visualizer. They're all having to do with the RockSim software, and I think I can try to help you. So if you have a question, you can go into the chat right now and type in your question. If you're just joining us, go ahead and put your name down and where you're watching from so that I can recognize you. I really appreciate everybody that comes to these. I know it's weird to have it on a Friday afternoon, but this was the only time in my week that I had available. We have Carlos from Marietta, Georgia, and Brave Timo from somewhere. He's watching. If you're new to RockSim, let me show you my screen so I can talk about RockSim here. This is the Launch Visualizer. Let me go over here to the Apogee website. This is the Apogee website where you'll find about RockSim. If you want to purchase it, go to the shop menu, click on the shop menu button, and then come down here to RockSim software, Rocketry software, and you get RockSim, RockSim Pro, or the upgrades if you want an upgrade. The Launch Visualizer is still in beta testing right now, so we're not taking money, but you can certainly play with it if you want. And if you want to learn how to use RockSim, go to the How To and Guides menu, and then come down here to software, click on that, and then you get all this information about using RockSim, like the FAQs, the features, how to purchase it, what's the version history, we're on RockSim 10.3 now. So what happened to like 10.2 and 10.1 and 9 and 8? So if you want to know those versions, you can go there. RockSim Live Training, we archive all of our training videos here on the Apogee website. So if you click on the RockSim Live Training, we are on episode number 46 right now. And like this was last week where we talked about the AGM 157 and getting a list of recommended motors into RockSim. You would look at those topics by clicking on the link here to YouTube and then just scrolling over to the time when those appeared in the video. Oh, okay, we got more people coming in. We got Retro Starship saying hello, Tim. MOB Rockets. Michael O'Brien from Mesa, Arizona. Awesome. Retro Starship says, I am from Massachusetts, here in the USA. Carlos K. writes, many payloads, like the Apogee egg tosser, widen around the payload, maintaining a circular cross-section. Can RockSim widen to an oval or rectangle to stretch a 13mm tube to fit over an altimeter? And the answer, unfortunately, is no. RockSim only does circular cross-sections. We can't do squares unless it is like a dowel attached to the rocket. I think we've talked about that before in the past, but the simple answer, Carlos, is no, it can't do wrapping around an altimeter. Okay. What else do we got? That's no question so far. I did have one come in over the last few days. He was talking about the Launch Visualizer, and this is the Launch Visualizer. And he went into the designs and found the flying machine. And the flying machine, as you can see here, is a unique design that has strap-on pods on the side of the rocket. And those pods can fall off during flight. And his email to me was, hey, I can't get it to work. What's going on? And so I had to, the last few days, I had to do some research into this And I discovered two issues. The first was my fault. In order for the pods were falling off. It's just he couldn't see them falling off because they had no recovery devices in them. And once it has a recovery device in them, then you can add flight events, which you can't do in RockSim, but you can do in the launch visualizer, and you can also do it in RockSim Pro. And then the second one was a bug. And now that we know there's a bug, now we can fix the bug, and our programmers are working on it. So I can kind of show you if you want to see it. This is the launch visualizer, as I said. So the first problem he had was he assumed that there was recovery devices already in the pods, and there wasn't. So that was on me. That was my fault because I created the file. And once you're in RockSim or in the launch visualizer, it's not a design program. It's only a simulation program. So I can't design in recovery devices into the pods if they're not already in the pods. And that's a known issue because we're just not at the point where we can design with the software yet or change the design once it's built. You can only change the motors or the launch angle, which is what the purpose of the launch visualizer is for. So the way to fix that is to go into RockSim and then add the recovery devices into the pods, and then come back, upload it into the launch visualizer, and then you can run your simulations. We've got Space Race Watcher Toxic saying hello. And Daniel O'Brien, hi from northwestern Pennsylvania. Any resources to use in a classroom for tech class? Where do I start? Okay, Daniel, start here at the launch visualizer. We want teachers to give it a try. The launch visualizer right now is free because we're in beta testing, so we're just trying to figure out all the bugs so you can use most of the features. And if you want, there are features that are turned off, but if you request to me just through an email, I can turn them on for you so you can run all these features. So like if you wanted to do what I'm going to do right here, this would be a lot of fun. So what I have already done is I reloaded the flying machine design into the launch visualizer. And I can show you how to do that if you want to learn, but I want to just kind of walk through this right now. And then I'll show you how we would set up having the pods fall off and what the bug is that we discovered that has to be fixed. So here is the rocket, and to set up a simulation, you just work down these buttons right here. So the first one is selecting a rocket, which I've already done previously before you got here and started watching. The next is the launch site. Where are you going to launch your rocket from? And we can launch anywhere in the world. Right now, this is kind of like a map of the world. It's loading the maps, as you can see. It's placing the terrain. I am currently, the red dot right here is located, I don't know if you can see it yet. Okay, see this rectangle box right here? That's the state of Colorado. And that red dot is right near Pueblo, Colorado. That's kind of like my home launch site. And that is the default launch site when you first start the launch visualizer. And if you zoom in on that, I'm keeping zooming in, and you can see the range setup. See these little dots right down there? Those are cars. And out here are the launch pads. And the dot is where the rocket is going to be sitting to when we launch it. And technically, that's not where the launch pad is for this site. I'm just clicking and dragging around, moving things around, so that's kind of why this is moving on you. So here is the launch control table right there, and then typically on this launch site, here are the low power pads, and then here are the H and I pads, and then the J pad is out there, and you know the high power pads go further out towards the northeast. So if I want to put the pad in the right spot, what I do is I just zoom in where I want to put the pad, and I want to, this is a concrete block that we put our launch pads on because it keeps the grass down, so there's no flammables around the launch pad. And so these two darker squares are launch pads. So I'll just put my launch pad for right now there by just double clicking. And you can see it put the dot where I double clicked, and then come down here and I just do confirm launch site. So now when it launches, it's going to launch from that spot right there. And you can do this for anywhere in the world on your launch site. And once you confirm launch site, what it does is it grabs the latitude and the longitude and the ground elevation at that particular coordinate. It fills it in. The landing zone altitude, it assumes the rocket is going to land at an elevation that's similar to what the launch pad is located. But if it's not, you can manually change it. So when would you manually change it? Say you were launching from the top of Mount Everest, the highest point in the world. The rocket is never going to land at that elevation because it's always going to land lower. So then you would have to kind of estimate where you think it might land and figure that out. That's a little bit harder to figure that out because you haven't launched the rocket yet, so you don't know where it's going to land. The second time you launch the rocket, you can look from the first simulation to see where it might be in the second one. So now we've picked our launch site. Now we have to pick our starting state. So a starting state is how the rocket is oriented on the pad. You can see in this particular rocket, it's kind of pointed straight up. This map here is also rotatable and movable. You can see on the ground, north is here, south is back, east and west. The rocket's kind of pointing straight up right now, but I can angle it. So I can just grab the angle here and just start angling the rocket over. See how it turned to red right there? That means this is not a safe launch. This violates the NAR safety code. If I go back more vertical, come on, grab you. See, it turned green. So under 30 degrees from vertical, it's safe according to the NAR rules. So now if I look at it from the top down, I am kind of launching to the north at an angle of 17.65 degrees from vertical. My launch rod length is 36 inches. And if I want to change things, I can grab these sliders and slide this one over here. So now I'm going more towards the east. And I can also change the roll orientation. So I can click and drag and see how the rocket is rolling. This could be important if you have a rocket such as this, where you have more surface area in one direction than the other. You can see this blue arrow right there. That is my current wind direction. The wind is coming this way, coming out of the west, hitting the rocket that way. So if you don't like the current roll orientation, maybe you want your pods to be facing in toward the wind. So then you would just grab your rotator here and then swing this around. So you can say, okay, so now it's coming 180 degrees, trying to get to 180. There we go, 180. So now the wind is coming, it's hitting it right along that edge right there. So, that might be good. When you're flying a glider, this stuff is important because a glider wants to kind of flop around on the launch pad. And the how you start it is going to make a difference. Okay, so that's the starting state of the rocket. So now we're going to go to the wind conditions. So this is in the simulation when the rocket returns to the ground. So once it goes up, it's going to come right back down to the ground. When you are in the demo mode, by default, it stops the simulation at Apogee. So if you want your rocket to come all the way back down to the ground, you have to send me an email and say, hey, I want to make an account where my rockets come back to the ground. This is for the beta, while we're still in beta testing. Once we come out of beta testing, that feature will be turned on as part of an upgrade, a paid upgrade. Where the rocket land is kind of important, so you know we need to make our money back by making this tool. So that's how we're going to make it. You know, it's going to be $3 a month, which is, you know, that's the less than the cost of a C engine. So it's not expensive, and you can fly hundreds of flights for the same cost as one C engine. Okay, so you can set your temperature and humidity and barometric pressure, and right now we have a steady wind, and if you want to see what that steady wind is, you click on it, and the wind is coming out of the west at 4 miles per hour. I'm going to change this to 8 miles an hour just to make it a little bit breezier. Oops, not 80. And click OK. Okay, so now we got to load the rocket motors, and I have already loaded motors into this. And loading motors here is very similar to how you load rockets in RockSim. I've got 3 engine mounts. I got the one in the middle and then 2 in the pods. And you can tell them apart. So they're all in the first stage, but this one here is right in the middle. So that's in my core vehicle. And then these 2, it shows them in the pods. I don't know exactly which pod, but it's not so important because they're both C6 motors. So I've loaded C6, and the ejection delays on one of the pods, I want to be able to see these coming off. And if they both come off at the same time, it's kind of hard to see them. So I want to stagger them. So I'm giving them ejection delays. So one's going to pop off at 0 seconds after motor burnout, and the other one's going to pop off 1 second after burnout. So I can see them. And then additionally, the one that's going to eject 1 second later, I'm also going to give it an ignition delay. So ignition delay is, okay, I push my launch controller button, and normally that fires the igniters and they take off. But on this one motor, there's going to be a delay of 0.5 seconds before that particular motor ignites. So 2 motors are going to ignite on the ground, and then when the rocket's in the air, a half a second, it's going to ignite. So it's kind of like, you know, the motor just didn't want to ignite, but it finally caught and it took off. So that's the way I have the motor set up. And then here's the flight events. Now this is what the person that emailed me said, hey, I'm not seeing the flight events. I can't deploy these pods. I can't see them falling. So the first file, the current file that's in the sample kits that come with the visualizer doesn't have streamers in the pods, and you can tell they're in the pods because this is like, this one here is, you know, showing it in this parachute is in the core vehicle, so it's in the middle of the rocket, and then these 2 streamers right here are in the pods on the outside of the rocket. So that kind of gives you an indication of where they are, and then each of those are going to be deployed at the maximum ejection delay of the motor that controls that one. So now the parachute, it is going to fire. Let me go back to the motor here. I got an E11J, and it has an 8-second delay. So the maximum ejection delay is 8 seconds. So after 8 seconds after the motor burns out, the parachute for that core is going to deploy. And on these other ones, one is set at 0 seconds and one is set at 1 second. So as it takes off, the motor burns out, immediately streamer comes out. On the other one, it starts a little bit later, and then it burns out, and then 1 second after that, then its streamer is going to come out. So that's what we want to see. All right, so now so all my flight events are set at maximum ejection delay. And now I can launch. And to launch, you click this button down here in the bottom that says click launch here. Before I do that, I want to say that, okay, so the bug is still in the software as of today, but hopefully by next week they'll find it and fix it. So when we launch this thing, it's not going to perform correctly. And then I'll rerun the simulation in RockSim Pro, which does perform the simulation correctly. So you can see the difference. Okay, so I'm going to launch. So I'm going to click launch, and it's going to say it's going to cost me 51 credits. Each credit is 1 Newton seconds of power. So that tells me, how much power I have in my rocket. The more power, the higher the rocket's going to go. I've got in my account 126,000 credits, so I'm only going to use 51. So it's nothing. So I'm going to simulate. And now it's running the simulation. And this simulation is going to take longer than a normal simulation because it's more complex. We got more things happening. So don't close the browser window while it's running. Okay, so it ran the simulation, and now it's loading everything into the launch visualizer. Okay, so now we're seeing the rocket on the pad. Remember, here's our concrete block that we talked about earlier. I'm just spinning this around so we can kind of get the lay of the land, see where this rocket is going to go. And it says this page is using a lot of power, which it does because these maps take a lot of power. Okay, so here is the rocket on the pad, and this is just a close-up view of the rocket. So you can kind of see, you got a far-away view and a close-up view. And right now, north is off to the left, and I can orient it around a little bit. And grab that and orient it. I want north pointing more towards the horizon. So so now north is more up. This cone right here is called the weathercocking cone, and what it does is it gives us an indication of how high the rocket's going to go and whether or not it's going to be a safe flight. And you can see this cone goes pretty high. So I expect my rocket to go about that high. All right, so now let's launch it. So I'm going to play this animation right here by clicking this button. And okay, the rocket's taken off. And you can see a close-up view here and the faraway view there. And at this point, the rocket is arcing over, you can see, and then right there, parachute popped out, and now it's descending under parachute. And so we can kind of see what's going on. So now the bug, I hope you can see what the bug is. The green line is the trajectory of the rocket, and it's still coming down under parachute, and it's at 31 seconds. When it gets to 40 seconds, it'll be all the way down to the ground. I'm going to pause it right there. But these green lines going vertically, those are my pods. Instead of my pods falling down to the ground as they fell off, they went up. They defied gravity somehow. And that's the bug. Why did they defy gravity? We don't know. I don't know, but my programmers they'll figure it out. So you can kind of see the trajectory here, and those pods shouldn't be up there because they're never going to go higher than the rocket went. But they fell off the rocket, so the trajectory of this rocket looks okay. I wouldn't say there's anything wrong with this trajectory here. It's just the pods, instead of coming down to the ground, they went up. And you can see my weathercocking cone, so the rocket stayed below the top of the cone, but it's outside of the cone, which is typically, this is not a safe, what I would consider a safe launch. You want to have that dot inside the cone, and if it's inside the cone, it will be green, and that tells me my flight went more vertical than horizontal. We angled this rocket pretty good. I think we have about 17 degrees. So if it was angled more straight up, it would probably be considered a better flight. Okay, so that is the bug that's in the launch visualizer, and it shows you the pods. So now I'm going to go to here to RockSim Pro, and I've got, here I can change the design. So I can change the streamers and things. So if I look at my streamers here, the S stands for streamer, so there's a streamer in that pod, and then there's a streamer in this pod. And I changed the colors so that we can see them. So let's go and load a simulation. I'm going to reload this simulation right here just because it's a little faster. So load engines. See, it popped the motors in. So now instead of an E11, I got a D12-7, a B60, and a C61. And let's go here to prepare for launch. And okay, so again, it shows me my motors that are in here. If I click on, I can change things if I click on them, but I don't need to change them. Flight events, this is very similar to what you saw in the launch visualizer. All the devices are set to deploy at maximum ejection delay. I don't have an icon here for the parachute, but that's a location and not a device. So the location I don't have, like we had on the launch visualizer, it was the center of the rocket that's colored. We haven't added that to RockSim Pro yet. Eventually we will. Starting state, 10 degrees from vertical, going kind of, this is our azimuth. Instead, north would be up, east is off to the left or right, south is down, and west is here. So we're kind of launching to the northeast. Launch conditions, this is our launch pad. I'm not sure where this particular launch site is. I think this is the one in western Colorado. But here you can give it a latitude and longitude and an altitude like we did before. And I've already put values in. I just want to run the simulation. So flight profile, and it's running the simulation. Okay, and so this is a screen that's very similar to the launch visualizer. You'll see the rocket on the pad, just like we did before. Now the background is green, and that's because we're on green grass. So I'm backing out to kind of give you the lay of the land. You can see houses and buildings and a pond down here, and we're in this nice field. Rotate it around. You see my weathercocking cone. Okay, so north, this road runs north-south, so you can get a kind of the lay of the land there. And I'm just moving things around so you can see it. So here's the rocket on the pad. And let's go ahead and run the animation and see the pods fall off. So the rocket takes off. Okay, so each of these dots here are the pods falling off. And then finally here is the apogee point of the rocket core. So these are the apogee points of the pods, those two, and then this one is of the core vehicle there. And now it's coming back down to the ground. And let me pause it here. Oops, pause. Let me scrub through this launch here real quick. Okay, so here's the trajectory of this rocket. And let me zoom in. Bring it in a little closer so you can see that it actually is working fine. Okay, so let me pan it up a little bit. Okay, so now this first one here is the first pod. Remember, we had that one was a B60, and the other one was a C6. So a C6 burns longer than the B6, so that's why it came off higher up in the air. And then the D motor in the middle burned a lot longer, and that's why it arced over here. But if I zoom in here at this one, You got to learn to move your rockets around or the scenery around. Okay, so here is where the first one fell off, and you can see its trajectory came down here. And if we zoom in down there, we'll see that pod. It's kind of hard. Okay, so there's the pod right there, and then you have the shock cord and the streamer up here. So that's the first pod. Then we go this way. Here is the one that came down to the second pod, and like I told you, I made them color-coded. So you can see the streamer here is a different color. Down there is the pod. And then finally, the main body of the rocket. It's still in the air at this point. Oops, I zoomed in too far, I think. It's a little touchy. I know it's, oops, let me zoom out. There it is. There's my core vehicle under the parachute. So that shows you that it's working correctly in RockSim Pro. We're still working on the launch visualizer. That's still in beta testing. So that's kind of why it still has some bugs. Let me go back over here and check, see if we got questions. Retro Starship asks, is the launch visualizer for Macs only, or do you use it on PC? The launch visualizer is a web application, so it's independent of whatever operating system you are on. You can run it on Mac, you can run it on Windows, you can run it on Android devices, you can run it on iPhone or iPad, because it's run in the cloud. You don't have to download any software to use the launch visualizer. You could use it right now. The web address is rocksim.com. So you can open up a different browser window as you're watching this YouTube, and you can play with it just like I'm playing with it myself. It's run in the cloud, which is the really cool thing, especially for teachers. I had a question about Daniel O'Brien. This is really good for schools because schools always have problems loading software onto their computers because they always have to worry about viruses. Because it's in the cloud, it's run on our servers. You don't have to worry about anything infecting your computers. Alfred Indy, RockSim launch condition screen. Default is 0. Should we this number to be above sea level for our area? Yes. If your area is above sea level and your launch is at sea level, basically that means you're underground when you're launching. And what's going to happen when you launch from underground is when you get here to this launch visualizer screen, what do you think underground looks like if you were seeing it on a picture screen? It looks black. So if you're seeing a black screen, you're underground. Don't launch underground because it's not very exciting. Johan de Slooper, hey, cool, the flying machine. Thought about that, yesterday, I think. Oh boy, with all those rivers, it would cost you a whole holiday season. So what you're seeing here in the launch visualizer on the flying machine, what he is talking about is the launch visualizer, or the flying machine. We designed it to be a steampunk looking rocket. So steampunk has all kinds of gears and bumps and rivets and, big heavy rivets. So if you go to the Apogee website at apogeerockets.com and you go to the search bar here at the top and you just type in flying machine, it will bring it up and you can click on it and it will go to the product page, and then over here is a picture of the rocket, and you can see it looks a little bit different, but then if you click on that picture, it'll bring up a larger view. And now you can start to see all the rivets that you have to put on this rocket. And that's what he's talking about. He said, oh man, it's going to take me all of the holiday season to put those rivets on. Maybe. There's ways to cheat. If you come down here on the Apogee page, you can see, you know, here's the pods falling off when you launch this rocket. See here, this rocket, 3 motors lit right there at the pad. If you come down here, keep scrolling down. Here's a video of the rocket actually launching in flight. And in the frequently asked questions, or down here, what have people used for the rivet dots? And here are 6 different suggestions on how to put those rivets on a lot faster. Different from what I do. So if you want to put them on faster, Johans, there you go. Daniel O'Brien says, thank you. This program looks great. I plan on playing around with it very soon. I am looking forward to the finished version. It's pretty close right now. We're just finishing up those last minute bugs. The main effort actually is on the payment system. Because we need to make money on it, so we have to be able to collect credit cards and charge people. $3 a month, that's all. Retro Starship says, oh wow, I have it now. Thank you. Okay. Any other questions that I missed? If you have a question, now is the time to ask. We have a good 20 minutes left in this session. Carlos K says, I am lazy. When I get to the launch site, I can ask NOAA for winds and direction. Will there be a programmer's interface so the programmer users can preload their variables? The answer to that is not currently. It's a feature we'd like to add. So he's talking about this goes for both RockSim and the launch visualizer. You can set up, I got the spinny ball here, that means something is open. This screen right here, I got to close this screen. You can adjust the winds to what they are actually. Normally, okay, so to adjust the winds, you go here to the prepare for launch, and you come over here to wind table. And this is where you put in your values for the wind. So now normally, when you go out to a launch site, and what you feel is the wind on the ground. The question is, are the winds above the ground different from what's on the ground? If you've launched a lot of rockets, you know that sometimes you get your rocket up in the air and the winds blowing up high are going a lot faster than the winds on the ground. So that's what the wind table does. It allows you to put in different values. What Carlos is asking is, can this be preloaded based on NOAA weather information? And the answer is no, currently. I know this is a popular request from a lot of people, so maybe in the future we can add that, but no for right now. If you wanted to change the wind, this is a lot of fun. Let's do it in the launch visualizer. So I'm going to cancel out of here. Let me open up the launch visualizer again. Okay, so you go to the launch visualizer and it's apogeerockets.com. Let me choose a different rocket. We didn't show you how to load a rocket. So let me do a refresh because something is not showing up here. No. Oops. RockSim.com. It has to reload. This is the cool thing, is you don't have to load the software because it's on our website. And it's loading right now. It just takes a couple of seconds. And you can see it's still loading the rocket here on the pad. Okay, so by default, it chooses the Avion rocket. Let me just double check to make sure I am logged in. I am still logged in. If you're not logged in, then when you get to some of these buttons, there's going to be a lock icon. That means those features are locked and you can't change the parameters. Once you're a premium user, everything is unlocked. And then you can start changing things. So I'm going to select the rocket design, or I can upload a rocket design. I'm going to select the design. So I'm going to come down here to choose design. And it's going to load. There's two types of designs. There's users designs. These are ones that I previously uploaded. And then there's the demo designs. So if you're in the demo designs, I think there's 7 designs in here. These are actually not the ones that are going to be in the final version, because there's extra ones in here. You have an Avion, the Skymetra, Egg Tosser, Sea Sting, an unstable rocket, the Apogee Diamondback, and the flying machine. This is the flying machine that doesn't have the recovery devices in the pods. So if you want to run what I just ran previously, you're not going to see the pods fall off because they don't have recovery devices in them. And then we have an Ibis. So let's choose, I want something that goes fairly high. So let's choose a Diamondback. I'll select that one. And then it loads the rocket here. And you can see this is what the rocket's going to look like. 3-fin rocket, kind of an odd shaped fin arrangement there. Launch site, let's choose a launch site. I'm currently trying to figure out where it is. This should probably be the Pueblo launch site, which it is. So I'm going to choose a launch site. I'll choose a different one. Doesn't matter which one I pick. Let's choose this one here. Click OK. This one is the one in western Colorado. I like it because it's got scenery. It's got those mountains in the background, which, you know, is so cool. You know, I think I've never actually been to this launch site, so I don't know exactly where the pad is located, but I'm sure it's not in a parking lot. So I'm going to go over here to an area and just double click there, and I'm going to put the pad right there. Confirm the launch site like we did before. Right now it's launched straight up. We'll give it a couple degrees of angle. Let's go to the west. Okay, so wind. So this is what we wanted to do. I wanted to change my wind directions. So over here, you give it a variable direction wind table, and this is the advanced one. And this is, we're going to create a new wind table. So altitude above sea level is 0, and the wind at sea level is 0 miles per hour. But we're not launching from sea level. Let me cancel this and just verify where we are. So here our launch site is at 6,590 feet. So when we go to the wind table, our first one has to be, oops, not that one, this one. Our first wind has to be 6,590 feet. So I'm going to add a new, can I change that? Yep. Okay, so you click on it and you can start changing it. So 6,590 feet. Let's say the wind is coming out of the west, which is 270 degrees. So 0 is north, east is 90, south is 180, 270 is from the west. So this is coming out of the west, blowing towards the east. And we'll give it an 8-mile-an-hour wind. And then we're going to add another altitude. So this one, we're going to say, let's make this second one 7,000 feet. So it's another 410 feet above the launch site. 7,000 feet. And let's say that this time the wind comes out of the north, which is 0 degrees, but it's going to be 8 miles an hour. So we got a 90-degree wind shift, which is really cool. Okay, let's add another one. Let's go another 500 feet up. So 7,500 feet. Let's make it from the 90-degree direction. So now the wind is coming out of the east, blowing. So on the ground, it's coming from the west, and at 7,500 feet, it's blowing from the east. So now it's 180 degrees different. And let's make it 8 miles an hour. I'll click OK. Oops, I wanted to go back there. I'm not done. I'm going to add another one. So now at 8,000 feet, which is 2,000 feet above ground level, let's make it 180 degrees. And let's make it 8 miles an hour. Oops, come on. 8 miles an hour there. And then let's go 8,500 feet. And it's coming back out of the west again. So basically what I wanted to do is make a circular spiral wind direction. Okay, so now we've got this rocket. In order to go through all the different wind layers, it's got to go at least 3,000 feet above the ground. So when we load a motor into this, we need a big motor. So I'm going to, I only got an 18 millimeter motor mount. So I don't think I'm going to hit the 3,000 feet. So I'm going to choose the biggest 18 millimeter motor that I can. So we got a D24. I'm going to sort it by total impulse. So the biggest one is a Klima D9. But let's say hypothetically I could put a G motor in here. So let's see if we can. So I'm going to show all the motors. Okay, so now I'm going to scroll down. I'll put in a G77. Yeah, and let's make it a really long delay, 10-second delay. Okay, so that motor, I've loaded in a G77 into this rocket. It only takes an 18 millimeter mount, but you can do that in this software. Okay, so now flight events, we have a streamer, and the streamer deploys at maximum ejection delay, which was, I think I set it at 10 seconds. Ejection delay is 10 seconds. So 10 seconds after motor burnout, the streamer is going to pop out. So let's launch this thing, and hopefully we'll go above 3,000 feet so that we can get in all the wind levels to see what this rocket's going to do. This should be a lot of fun if it works. This is educational. This is what Daniel O'Brien should be playing with his students. All right, so we got a black background, which means somehow we're underground. So if I zoom out enough, I can be above ground. It's not good to be underground. Let's see if the rocket will come up out of the underground. It does look like it will, because it's going to be 152 seconds. Let's change the view here to this view. Oh, holy! So let me zoom out. So can you see the weathercocking cone here? So you can kind of see, here's the weathercocking cone. If you brought both sides down, we're probably launching that far underground. But let's launch it anyway. So we launched it. We're still underground. Okay, now we popped up out of the ground. Rocket's taking off. It's wobbling around a little bit up in that upper atmosphere wind. We're at 4,200 feet right now, so we did go higher than 3,000 feet. And now it's coming down. And because it has a streamer, it is falling fairly fast. And I wish I should have selected a rocket that had a parachute in it. Yeah, because it has a streamer, it's coming down really fast. Let me pause here, find out where the rocket is right now. So I just click this button. It says the rocket is still right there. There it is, right there. Yeah, and it's just falling straight down. I need a parachute. So let's pick a rocket that has a parachute. So choose design. Pterodactyl 2-stage. Select rocket. I gotta figure out why I was underground there. $65.90. I should be above ground. My wind, I still have variable direction wind, so my wind table is still the same. I still have this 8 mile an hour, swirling wind, except for right here. 8 miles an hour. Okay. And then to load the motors into this one. This one is a 2-stage, so maybe an F to an F. F12. I'm just scrolling down. I'm trying to find the Estes F15. If you can't find it, come here to the search bar. F15. Here it is. F15. Ejection delay. Let's call it 8 seconds. Click OK. So that is in the upper stage, which is this part here, and then the bottom stage we'll load the same one. So I'll just click load all. It loaded that one into the bottom stage, but it also has an 8-second delay. And I want to make that let's make it a 0-second delay. But let's make the upper stage have an ignition delay of a second. So the motor will pop off, it'll coast for 1 second, and then fire off the upper stage. On flight events, we have a parachute and the staging at max ejection delay. So this one has a parachute, so when this one launches, we should see some swirling wind. And if you've never played with swirling wind, it's a lot of fun. This is why I'm playing around here. Okay, Johan, I'm looking over here at the questions. Okay, so now, I'm coming back here to the screen. I was looking at, while I was running that simulation, I was looking at the questions. Okay, so now we're at the ground. We're not below the ground. And you can see the height of the cone. It's going to go pretty high. So I think we're going to get to our pretty high altitude. And this one's going to hang in the air for a lot longer. Okay, the rocket takes off. See the motor here still burning, It burned out, dropped away. Now the upper stage ignites a half a second or 1 second later, and it's going off. It's going off into the to the west. All right. Okay, so now let me look at it from a bird's eye view, from looking straight down, so we can kind of see what's going on here. We're at an altitude of 2,200 feet. And the rocket is drifting down, and currently it's like right here, going across the highway. I should be into my wind shear. Okay, so, all right. Do you see what's happening here? So the launch point was right here. The booster stage fell off here, and it fell down here. The rocket arced over, and it popped out its parachute here, and it started descending, and the wind was coming out of the west, so it was drifting west, but now we're getting into the swirling wind. You can see it's making a number 2. Now it's going back across the road. And it's still at 1,000 feet. Still curling, 700 feet. It's going to probably land in these trees right here. While it's landing, we're another 30 seconds away from landing. Johan says, "You want question, huh? I can make one up. Can you calculate the time between drogue chute deployment and main chute with the desired height deployment of main parachute with RockSim Pro? Can you calculate the time?" Look at that. It started curving around the other way as it's getting closer to the ground. Is that cool or what? Let me pause it and drag the slider all the way down to the end. Come on. This the launch visualizer, because it's on the website, it's a little bit slower than RockSim Pro as far as being able to drag this along. So now you can see the trajectory, and let's rotate it down. Is that cool or what? That kind of looks like a roller coaster ride. That's a lot of fun. And then notice that the booster stage did the same thing. Its trajectory also curved because it was in the same winds as the main part of the rocket. And the booster was just tumbling. So I get my booster back, but I'm going to be looking in the trees to get my upper stage. So it landed right over there in the San Juan National Forest. Okay, so he wants to, I'm going to close this. I don't think we're going to have time to go back there. Calculate the time between drogue parachute and main parachute. So we need a rocket that has dual deployment. So I'm in RockSim Pro because you can see that here at the top of my screen. I'll just take this rocket right here. It doesn't matter. I'll have to put a parachute in it. Do I want to save my changes? I'll save those changes. Why not? Okay, so this is a rocket that we showed last time that we just got this rocket in. This is called the Scorch. And this is from North Coast Rocketry. And it's an F engine rocket, F or G, so you can see that. Rocket design components. I only think this has one parachute, so we need to put in a second parachute. So I'm going to put in a streamer so we can tell it apart. So here's streamer. I just put in a 4-inch wide streamer. It's right there. Let me change the color. I'll make it orangish red in 3D. I'll do the same thing in 2D. Okay, so there's the streamer. Okay, so let's set this up for dual deployment. Okay. So let's choose an engine. I'm not exactly sure what the question is. So for dual deployment, we're going to use electronics to control everything. So I'm going to say this is a plug motor. just so that you can see that we're going to set everything up with electronics. So under flight events, I have my two devices, the parachute and the streamer. Right now they're both set at maximum ejection delay, which is plugged, so they shouldn't come out at all. And if we want to confirm that, let's launch it. I'm going to change my launch rod to 60 inches. Simulation controls, launch conditions. Okay, so this is that launch site that we were just at. Wind table, this one is only an 8 mile an hour from the west. Flight profile. So I'm just running a baseline simulation just to see what the trajectory looks like. Okay, so that's that same launch site we were at before. I'll put north to the top, and let's launch it. Rocket takes off. And since there's no ejection charges in this thing, I expect the rocket to just arc over and come straight back down. See, it's arcing over, and now it's coming straight down. And I'm going to pause it here at the right when it gets to the bottom. Okay, so it landed in that, just on the edge of those trees. Straight up and pretty much straight back down. Because we had it angled a little bit, that's why it went that way. Okay, so now we're going to set up dual deployment. So we'll go back here, and we're going to go to the flight events. So now his question is, he says, oh, I came up with a question, but my brain already answered it. Okay, well, let's do it anyway. We're going to set up dual deployment. So the first one is the streamer. We want that one to come out at Apogee. So our electronics are going to fire off the streamer at Apogee. And then the main parachute, let's set that one to a altitude of 300 feet. Now RockSim Pro is different from RockSim and the launch visualizer. Setting up events is more complicated because there's more options. So if you want to set the main to come out at 300 feet above the ground, you have to set up special conditions. If we just chose altitude of 300 feet, what's going to happen is that the parachute is going to come out at 300 feet on the way up. Let's turn the streamer off for right now and just show you that. Flight profile, let's launch it. And you can see it only made it to 347 feet. I don't know if you saw that real quick. It popped up. But basically, the parachute came out at 300 feet, but it had so much velocity, the rocket kept going up, dragging the parachute up with it. And then finally it flipped over and then came back down. So watch the altitude here. Let me zoom out a little bit. Let me change this to that angle. Oops, okay, now I'm too far zoomed out. Okay, rocket takes off. It's going really fast. Oof, and the parachute popped out. So this is normal in RockSim Pro. This is not a bug. This is by design, because you can set up simulations. Maybe you want your things to happen on the way up. And RockSim Pro gives you that versatility where you don't get it in RockSim or the launch visualizer. Okay, so now to set up dual deployment, you have to set up conditions. So the first condition is that we have to reach Apogee. So that parachute, before it comes out, it has to hit Apogee, and then we're going to add another condition to it and says it has to be at an altitude of 300 feet, but not greater than 300. See the greater than sign? We want it to be as soon as it drops below 300 feet, pop it out. So I'm going to change that to a less than. So now when it gets less than 300 feet, now deploy the parachute. So let's run it again. And again, I'm going to keep the streamer furled up. It's not coming out. Look, you can see that the rocket's gone a lot higher, 2,781 feet. And it's going to take in the air 39 seconds. Ooh, we're running out of time here. I'm just looking at my clock. We're almost done. So, okay, so now it's going up, up, up. It's going really high. Okay, now it's coming down and it's screaming down. Here's our altitude. So we expect at 300 feet to something to happen to the rocket. So watch the rocket. As soon as it gets to 300 feet, flip, it just flipped right over. And now you see it coming out, the dual deployment. See, now at this point, let's pause it. Let's center on the rocket. So I know that my rocket is directly centered, and I can zoom in and I can see that the parachute is out. Okay, and then eventually it'll just go back down to the ground. And it's going to land in those trees. So that's almost dual deployment. Now we just have to change the streamer. Okay, so I'm going here to prepare for launch, flight events. Now our streamer, typically we deploy that at Apogee. So I want to find Apogee. So I'm going to say deploy at Apogee. And it calculates it automatically, flight profile. So now we are set up fully on dual deployment. And Johannes Disloper says, yes, I meant delta time, change in time. There are, like you saw in RockSim Pro, you can change time. I think there's one little bug in there that has to do with time. Again, this rocket went 2,782 feet. Why is it taking so long to load my launch visualizer? Oh, loaded the launch visualizer on the other screen. I've got two screens going on here, and it put it over here. So why isn't it in my screen? So it goes to the same altitude before it landed here in these trees. Let's see if we can miss the trees this time by having the streamer deploy. Because it has a streamer, it's going to still fall fast. It probably won't land in the same spot, and it is definitely a different time, but the time is only a few seconds different. So at this point, the streamer's out because the rocket is more vertical, and it's coming down. But it's coming down pretty fast. I'm going to speed things along here. Okay, we're at 500 feet, 400 feet, and at this point, so now the parachute is out because you can definitely see something has changed. It's slowed down, and it just made it across the river. Oops, okay. I'm going to bring it back here just so you can see the entire trajectory. Rotate it around. That's pretty cool. Nice flight, I think. It went pretty high, 2,700 feet, and it didn't land in the water. So I'm happy. Okay, so that is running simulations in RockSim Pro and the launch visualizer. Yeah, we're done. So let me go to the different screen here. Okay, so I think I had a lot of fun today. I showed you some bugs. We're fixing them. We're working on them. This is a complex program. This is rocket science. I can say that. This is complex stuff, and RockSim Pro and the Launch Visualizer simplifies things, and it's a lot of fun to play with. You learn a lot. I'm always learning. You know, when we did the circular wind patterns, it's kind of what do you expect in real life? What's going to happen? Okay, so we're going to come back again next week Friday. It's 2 p.m. Mountain Time Zone, which is 4 p.m. on the East Coast of the United States. I'm not sure what time that is over in the Netherlands where Johan is. I think he's in the Netherlands, I think, from before. Yeah, so we'll be back again next week. Same time, same place. Have your RockSim questions ready so that I can answer them. And if you like to play with it, you know, go to rocksim.com for the launch visualizer, or apogeerockets.com to purchase or to download the demo version of RockSim. Or, yeah, there's only a demo version of RockSim. There's no demo version of RockSim Pro, because basically RockSim Pro is the same as RockSim, except for you get the launch visualizer already built into it. Okay, so I am going to end the stream here right now. So thanks for coming, and we'll see you next time. And in 5, 4, 3, 2, 1, go out and launch.